Hey yo, what's up? YouTube, it's your boy Joshabraham. Last time, general chemistry, I was done with line spectra. Next, we have Bohr model, combining knowledge of Rutherford nuclear atom and necessity to explain light spectra led to the formulation of Bohr's model with following three postulates. Only orbits with certain radii corresponding to specific energies are permitted. For the electron and the hydrogen atom, the first orbit is closest to the nucleus. For n is infinity, the energy of the electron approaches zero. An electron in a permitted orbit is in an allowed energy state. For this reason, it does not emit energy. Dude, at we got 302. We're at 40 right now. Come on. What is next one? It's still Bohr's model for this energy states of I quantized orbits. Electrons can only exist in certain allowed orbits with specific radii and energies. Yeah, stability of the electrons. Electrons do not emit energy while staying in permitted orbit. That's why atoms are stable. Energy emissions or absorption electron only emits between allowed orbits. The energy is quantized. Photon energy equals the energy difference between two orbits. Why it's important, explains the line spectra, introduces the concept of quantized energy levels. Okay. I can't copy it? Okay. Let's see how apply these concepts by considering transition in which electron moves from 3 to 1, equation 6.6. However, Bohr's model suffers from several shortcomings. It only works with one electron and not for multi-electron atoms. According to classical physics, the electron should lose energy and fall into the positively charged nucleus. The model violates the principle of Heisenberg's uncertainty. 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 Tainity. Uncertainty. As radiations can be described as wave-like or particle-like, also matter should possess wave properties. The concept of matter waves allows to solve problems related to Bohr's model. Concept of matter waves for connecting matter from wave particles. For connecting matters with wave particles, De Broglie formulated the following equations: frequency. No, 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 no. Where's frequency? Okay, the wavelength. That's wavelength, not frequency. Wavelength equals h by p. Electrons orbiting around the nucleus can be described as waves, matter waves. The wavelength of these matter waves depends on the mass and velocity of the electrons. Momentum, as can be understood from the equations above, reasonably small wavelength are only obtained for very small values of mv. Matter waves for larger particles have so tiny wavelength that they're almost unobservable, so matter waves only play a role in microscopic world. The concept of matter waves. Quantum mechanic treatment of an atom. The Schrodinger's equation succeeded in describing both wave-like and particle-like behavior of the electron. Electron is seen as a standing wave. The solution for Schrodinger's equation provides a wave function describing an electron. Heisenberg's uncertainty does not allow to determine the position of electron exactly. Only the probability density of the electron density can be given. I remember reading this. Okay. Quantum mechanical treatment of an atom. N equals 1 standing wave. N equals 2. N equals L equals lambda by 2, L equals lambda, L equals 3 lambda by 2. Can I copy this? No. Wave function. Electrons as waves and particles. Electrons exhibit both particle-like wave-like behavior. They are not tiny planets orbiting the nucleus, but quantum objects described by a wave. Schrodinger's equation, the fundamental equation of quantum mechanics of an electron. Its solution is a wave function which contains all the information about the electron. The electron forms a standing wave around the nucleus. Only certain wave patterns are allowed. Probability density gives a probability of finding the electron at certain location. Quantum mechanical treatment of the atom. Schrodinger's equation describes the wave-like and particle-like behavior of an electron. So H what the explain how the equation proved it, because I don't understand. Why is GPT taking a lot of time? What the? Is it because something's running? Quit. It's a differential equation that describes how wave function of a quantum system changes, where h is the Hamiltonian operator, total energy of the system, kinetic plus potential, E is the energy of the electron, wave function describing the electron wave-like behavior. When you solve the Schrodinger's equation for an atom, The solution wave function looks like standing waves around the nucleus. Only certain wave patterns fit these corresponding quantized energy levels. This explains why electrons show interference and diffraction in the experiment. Wave-like phenomenon, particle-like phenomenon. Although I forgot the name of the symbol. So wave. When you measure the electron, you always detect a discrete particle at the specific location. The probability of finding it is given by absolute value square. So the electron is a particle that behaves like wave. Its motion is described by a wave function, but measurements and detect the particle how it's proved. Before Schrödinger's equation mathematically combined both concepts. Wave function. Uh, can you explain using an example? Because right now it's just equations. I cannot visualize anything. Quantum mechanic treatment of an atom, wave function, solution of Schrödinger's equation, probability by electron density, what? Radial probability function leads to orbitals. Schrödinger's equation yields a set of wave functions are described by three quantum numbers. Principal quantum number, azimuthal quantum number, magnetic quantum number. Corresponds to Bohr's n possible values. Energy of an orbital increase. Imagine the electron around the hydrogen nucleus. Classically, we think it's orbits like planets. Quantum mechanically, electron acts like a wave around the nucleus. Electron wave can only fit around the nucleus in certain patterns, like vibrating strings on a guitar. If the wave doesn't fit perfectly, it cannot exist. Only certain patterns. Each pattern corresponds to a specific orbit or a shell. Probability cloud. The wave function describes where the electron is likely. Okay. You used hydrogen atom. So tell me how using the equation you could prove the wave-like and particle-like I forgot the term behavior. Just use one atom, one H atom. Set up the Schrödinger's equation for hydrogen. Angular momentum quantum numbers. Hmm. For a hydrogen atom, one proton, one electron. The Schrodinger equation is where H is H squared by first term kinetic energy of the electron, second term potential energy of the from the attraction to the proton. Wave function depends on the position. Solve the equation. When you solve it analytically, the solutions can be called orbitals. Each orbital is a standing wave around the nucleus. The allowed energies come out naturally. Only certain waves fit the nucleus. Mm, Wave-like behavior. Electrons form a standing wave, not a continuous orbit. Explains quantized energy levels and why electron doesn't spiral into a nucleus. Probability interpretation, particle-like behavior. I don't know. You did. I still don't see how you proved it. Also, keep in mind I'm a beginner to chemistry, so I might not understand the whole uh, could you explain more detail? Don't see anything. Also use values. Let me see if YouTube, there's something on YouTube. Uh, don't worry about the complicated math. I want to worry. You feel me? So what is H? Come on, right? What the fuck is an edge? The electron feels an attractive force from proton, which is by this equation. Yeah, now it's starting to make sense, but but can you make it more? Can you explain all the uh because I saw a lot of constants and I don't know what they are from. Also explain which which equations you use for the you know though these are the principal quantum numbers type shit. I do remember these: s orbital, p orbital, d orbital, f orbital. I'm sure there's gonna be one question from this. Then we switch to periodic table. For an element, its electronic configuration can be written as sulfur. For a chemical reaction, primarily electron configuration of outer shell is of importance. Okay. I gotta charge my watch, but right now my phone is charging. Okay, H is the Planck's constant, relates energy of a photon to frequency, shows energy is quantized. Reduced Planck's constant appears in Schrodinger's equation to simplify formulas used in wave function derivatives. Electron mass of an electron appears in kinetic energy terms. Elementary charge, Schrodinger's equation, where the Hamiltonian what just what I was reading. I was reading this name, right? Where's that name? Hamiltonian equation or something. What Just vanish? Potential energy is Coulomb attraction, Coulomb constant, F equals Q1 Q2 by R cube. K, where is K? K, Coulomb constant, E square, what is E? Elementary charge, okay, by R. Distance from nucleus variable. But I think for hydrogen it's solve the equation discrete wave function and quantized energies 13.6 by n square ev. This proves wave-like behavior. Only certain standing waves fit around the nucleus. Quantized energy levels. Particle-like behavior. Measurement detects the electron at a point in the probability distribution. Again, could you explain more? 30 minutes? God damn it! I cannot even understand the equation within 30 minutes. Could you again explain how this equation proves both of because I don't see it. I don't see it. So you can see how it connects to wave-like. No, I cannot see. Wave-like behavior. Schrodinger's equation treats the electron as a standing wave around the nucleus. When we solve it, only certain wave patterns fit. So comes directly from the wave pattern. If an electron were purely a particle moving classically, its energy could be any value, not discrete E1, E2. Mm-hmm. Uh, in fact, okay. So Schrodinger's equation. Uh, if I have to write this, how would I write this? E of n equals minus 13.6 by n square ev. This proves that it's a even though the electron is mathematically a wave, when you measure its positions, it detects its specific point. The wave function gives the probability density, telling us where the when the electron emits or absorbs a photon, it behaves as discrete particles. It jumps between energy levels in a single quantum. So also shows particle-like behavior. Energy changes occurs in exact packets, not gradually. Okay. So change. I understood that change in energy levels or result in and each ends are each energy levels but could you explain how the uh, n results in the proof of behavior, wave-like and particle-like behavior? N is the principal quantum number, which comes from solving Schrödinger's equation for a hydrogen atom. Hey, sorry, start a timer for 15 minutes. Only certain wave patterns fit around the nucleus. This corresponding gives the specific energy levels. So the fact that only discrete values of n are allowed is directly a wave phenomenon. It's like how certain wavelengths produce standing wave on a string. Standing wave on a string. What the fuck was a standing wave? Okay. How is it the wave function, wave-like properties? Only discrete values of n are allowed is directly a wave phenomenon. Could you explain this sentence with another simple example that results in wave function or like uh, the tidal waves. Even though the electron is described as a wave mathematically, it's detected as a particle in experiments. When the electron jumps from, so just because it has a certain energy level, we conclude it as a particle. Tidal wave, in a way, imagine a tidal wave small aspect like if you make waves, not every wavelength fixed perfectly between the shores. Only certain waves produce stable standing waves where peaks and troughs line up the wave boundaries. These are allowed wave patterns like certain allowed standing wave pattern in the bay equals allowed electron wave function. Forbidden electron energy, what the fuck is that? E equals minus 13.6 EV by n square. That proves. Wave function describe the electron as a standing wave. So Schrodinger's equation was, not gonna lie, I forgot. Kinda forgot. Just a minute. Just a minute. I need to see the original equation E. Okay. I'm sorry. H. I was right. Ugh. Don't ask me what all these values mean, but E of n equals minus 13.6 by n square. What am I doing? This equation basically proves that electron has both wave-like and particle-like properties. As E is n dependent. So, wave function solution equation leads to orbitals. Radial probability. Schrodinger's equation yields a set of wave functions as described by three quantum numbers. Schrodinger's equation gives a wave function for each electron, where it's a mathematical description of an electron state like shape of its wave. But square, what? Gives the probability density, how likely it is to find the electron at the particular point in space where square is large, the electron is more likely to be found there. It's a wave function. It's a mathematical description of the electron state, like the shape of its wave. Okay. So if you square the wave function, or absolute value equals probability density, helps in finding the probability of the electron at the given position. Radial probability. Atoms are roughly spherical, defined where electron is most likely to be at a certain distance from the nucleus. We multiply by the surface area of a sphere. This gives the radial probability. Okay. Okay. 4 pi r square wave function absolute value. That would be the radial probability. Tells us how far the electron is most likely from the nucleus. Orbitals. Each unique wave function corresponds to a specific orbital and allowed region where the electron is likely to be found. Different orbitals have different shapes. Each unique wave function corresponds to a specific orbital and allowed region where electron is likely. Okay. Value results in a specific orbital. A place in the atom where electron is most likely to be found of wave of the specific wave function. Each is described by three quantum numbers. So each quantum number is basically energy levels. No? Oh yeah, it's energy levels. Angular momentum quantum number. Uh, and each described by three quantum numbers: principal quantum number, angular momentum quantum number, magnetic quantum number. Could you explain how these numbers are related to the wave function, like the equation E equals minus 13.6 by n squared? Oh, we got n here, okay. Okay, it's basically n and minus 1. Okay, this one's different. No, it's kind of same. It's kind of same. 15 minutes? I got one more 15 minutes to learn. I should make maximum use of that 15 minutes. But before that, push ups. That's because of hydrogen. Okay. Let's reset a timer for 15 minutes. I understood that N means energy levels. For N. Is it some sort of assumption? I think it's an assumption, right? There is no concrete proof. No assumptions. Okay. Okay. Radial part depends on how the wave changes with distance from nucleus. We got mosquitoes. Mosquitoes in the winter. I'm not trusting these MFs. Not even joking. Radial part depends on how the wave changes with distance from nucleus given N and L. How depends on how the wave changes with distance from the nucleus R. This gives N and L. Angular part depends on how the wave spreads in angles given. How L determines shape. When solving the angular part, the mathematics uses spherical harmonics, special functions that describe wave patterns on a sphere. Wave patterns on a sphere, okay. Each L value corresponds to a different pattern. Perfectly spherical, this orbital, two lobes. I'm still trying to figure out how. How did you come up with the two lobes? I know it's two lobes, four lobes, you know. I know the shapes of these orbitals, but I cannot figure out how you come up with these. So the shapes is not guessed, it falls out naturally from which wave solution. Could you explain how each right, you said using a special function that describes wave pattern on a sphere. Could you show me that function and how that function concluded with these different shapes? Because the S orbital, a sphere, I kinda understand, but P orbital, dumbbell shape, I just can't figure out what equation of a sphere led to that shape. Sphere, stupid. Angular part of Schrodinger's equation. After separating variables, the total function becomes the second term y. It's called the spherical harmonics. It determines the shape of the orbital. The equations for spherical harmonics. Y1m theta s set. I forgot the name. Associated legendary polynomial. New terms. Defines a shape in polar angle. Describes how it varies around azimuth. Uh-huh. Normalization constant. How create shape 0. These are two possibilities. M constant value spherical shape. Okay. These are three possible. These the cos theta and sine theta in terms introduce positive and negative regions above and below the equator. Above and below the equator. Okay. Gives two lobes with opposite faces. Could could you when a sphere vibrates, the displacement of its surface can be described as spherical harmonics, the same function used for atomic. Okay, different. When a big earthquake hits, the entire earth can ring like a bell. For the vibration pattern, if you map this on a globe, the north hemisphere moves upward. North hemisphere moves upward, and southern hemisphere moves inward. What? that gives two lobes. I'm kind of having a hard time. God damn it. Okay, okay. North while contracting in south. Slightly expanding in north while contracting in the south. Mm-hmm. Okay, okay, I kinda get it. I'm kinda getting it. So, in case would the your average Sans fan, I like Undertale. Me too, bro. Not gonna lie. I really appreciate your average Sans fan for checking out the stream. I'm actually sorry if you find the latency a bit annoying. I know I still haven't figured out how to change the latency. Your average Sans. But I gotta go now. Have a great day. To you too, my brother or sister. Respect for checking out the stream. 15 minutes. Let me get this mosquito. Okay, now just. Or escaped, I guess. I don't know. So p orbital. Schrodinger's equation yields a set of wave functions which are described by three quantum numbers. Okay. So could you tell me the three quantum numbers related to the quantum function related to the wave function? The function, what was I thinking? I just how related like are they derived? ChatGPT is getting so slow. What the? Back in my day, this guy works really fast. Now look at him. Slow as fuck. Yes, all three quantum numbers come directly from wave function. They are an assumptions. They fall out of the math. Start with the quantum number boundary conditions. They are mathematically linked. Maybe I'm stupid. But when you say mathematically linked, it's not registering in my head. Like, how are they mathematically linked? I mean, I saw the equations, right? Yeah, it was something. These numbers are not arbitrary. They arise because only certain standing wave solutions fit mathematically. Mathematically. Okay, I kinda understood. So if I'm done with these, I could start. No, there is a bit. I could start with periodic table. And if I start periodic table, I would be at page number 74. I still got about 230 pages. We're just scratching the surface. Well, I'm gonna end the stream, YouTube, cause I gotta cook. Yeah, and I gotta call my parents. You know how it is. You know how it is. Peace out, YouTube. I'll continue after my daily stuff.